Welcome to the Math 1 lesson summary video for the task Getting Ready for a Pool Party. So it's important to keep in mind that this is a develop understanding task. So as you can see at the top, the purpose of this task is to develop the ideas of features of functions by using a relatable scenario. So we're not trying to become masters of all these types of features of functions and how to find them all and how to define them all. We just want to draw them out. What are the features of a function? What is a function? And we want to begin to think about what are the terms that we're going to be using throughout this unit as we dig deeper and deeper. But for now, we just want to introduce it and develop our understanding of these features of functions. So the scenario, the relatable scenario, is Sylvia has a small pool full of water that needs to be emptied and cleaned, then refilled for a pool party. During the process of getting the pool ready, Sylvia did all the following activities, each during a different time interval. So it's very important to keep in mind that the order is not specified. These 6 things could happen in any order, whatever makes most sense to you. So if you haven't already, it's important that you pause the video right now and try to create your own graph of the situation, representing all 6 of these possibilities in the order that makes most sense to you on a graph. So if you're continuing with the video now, I'm assuming that you've already paused and you've already created your own representation, and now you're going to compare with mine. Keep in mind, mine is just one way of looking at the situation. It could have been done in a different order. There's no right or wrong answer for this task, but there are some key things that we want to draw out from any representation. So first and foremost, whenever we have a graph, we always want to label our axes. So we're talking about time down here, and we're talking about the depth of water up here. And so for my scenario, considering the pool, you can see I have a scale on the bottom, but I've left the scale of depth of water off on the side because it's just not really important for this task. It's also not important as much what my units are on time, but to make you feel like we're doing a thorough job, I'll give it units of minutes. So before we continue to look at the features of functions, let's consider what a function is. So a function is a relation in which every x goes to one y. So in this case, our x is time and our y is depth. So at every time, there should be only one depth. And so you can see for any time that I select, if I look up, there's only one point on the graph. That's the depth at that point. At this time, there's only one depth. At this time, there's only one depth. It's okay that there's the same depth at multiple times, but every time is going to only one depth. Now, if I had this random extra line in here, that would be a problem. It would make this not a function because this time would be going to 2 different depths, and that can't happen with a function. But as it's drawn, as long as there's no places where the time goes to multiple depths, that makes it a function. The first thing that's happening in my graph, and you may have done something different, that's fine, is that she is draining water with a hose. So we can see scenario 1 right here. We've got the drain with a hose. And so that's what's happening first. For me, the thing that happens second is this set of 3 steps is to drain with a single bucket. And so you can see the reason it's steps is because the depth changes and then it stays flat for a while she goes off and dumps that bucket somewhere else. And since each step is 2 minutes long, I'm assuming for my scenario that she had to go dump the water in a very specific place that wasn't exactly super close, because that's, you don't want to just dump pool water in your yard. It can mess up your plants, it can mess up your grass. So she had to maybe walk around to the front of the house and dump it down the street gutter for my scenario. Again, that's why there's so many possibilities for this, because so many aspects of this are open to interpretation. But one key idea is when we get to step 3, part 3 of my graph, that's the 3 buckets. Notice one way I can tell that this is 3 buckets is because the gap between these steps, this gap here, is much bigger than the gap between the steps in step 2. So it's important that whenever you place these, that your gap when they were using 3 buckets is larger and around 3 times as big as the gap when Sylvia was doing it by herself. And I chose that she was doing it by herself first because I imagined that she was doing it, she got frustrated, so then she went and got 2 of her buddies to help her out. So then we get to a point where the pool is empty. And so she's cleaning the empty pool. So I've called that step 4. And so that's going to be this little spot right here. So around 4 minutes that she spent cleaning the empty pool. So not a super thorough clean, but enough to do the job. And then she took a break. And that's what I'm representing right here. So we have the cleaning and the break. For the cleaning and the break, notice in my scenario that the pool is empty. Now you could have had her take the break right here and your graph would have started to become flat at that point. But I'm choosing to have her take the break when the pool is empty. And then so that leaves finally part 6. The pool's getting filled with a hose. And of course it would have to keep going until we got back up to the same height as what we started, because the pool is being refilled to the same height as it started. But I just ran out of space on my graph, so I can draw that little arrow to indicate that. So let's start to talk about some of the features of functions that we want to consider in this graph and in any function that we encounter. So the first one that comes to mind for me is slope. So I'm speaking in generic units here because we haven't specified the units on the y-axis for depth of water. But if I want to find the slope of the draining with a hose, I can see that it was going down 2 over 1. So the slope would be -2 over 1, which is -2. Whereas over here, when we were filling it with the hose, the slope was +2 over 1, which is +2. So you can see it said that the filling with the hose and the draining with the hose needed to be at the same rate. And so they are, because the magnitudes are the same. The negative on this slope just indicates that the water level is going down, and the positive on this slope just indicates that the water is going up, but they have the same magnitude. And so we have slope is a key feature of a function only for linear functions. If it's not a linear function, if it's not a straight line, then we refer to it as rate of change. So I could talk about the rate of change for the single bucket steps, I'll call them. And that rate of change is smaller than the rate of change for the 3 bucket steps. So it's actually at the 3 buckets, the rate of change is 3 times as big as it was for the single bucket, because 3 people with the same size buckets are going to be 3 times as fast as 1 person with a single bucket. And so those are 2 important vocabulary terms. So let me clear this off. So another thing we might talk about would be the maximum value. And so that would be up here, the maximum value of depth of the pool. We might also talk about the minimum value, which would be anywhere down here in steps 4 or 5. We could talk about the y-intercept, which in this case happens to be the same as the maximum value. So the y-intercept is the place where the graph touches the y-axis. And then down here, all along here, we have x-intercepts, which are where the graph touches the x-axis. So a function can only have one y-intercept because of the definition of a function that every x can only go to one y, but it can have multiple x-intercepts. And then the last thing that we want to talk about from this scenario with regards to features of functions is the idea of increasing and decreasing, which we kind of already talked about when we spoke about slope. So here we have that the depth of the pool was decreasing. We can clearly see it's going down. Whereas over here during this stretch, we saw that the depth of the pool was increasing. And so those are some of the types of things that we're going to look at throughout this module as we analyze functions and their features. Slope, rate of change, maximum, minimum, y-intercept, x-intercepts, intervals of decreasing and intervals of increasing. And the purpose of this task was just to introduce you to those terms in a context to make it easier to connect back to understand as we move forward. And I almost forgot to mention, we'll continue to talk about the terms continuous, such as steps 1 and 6 were continuous in this case. And we'll also continue to talk about discrete. So in my graph, the discrete portions of the graph were steps 2 and 3. Thank you for watching. If you need help with the Ready Set Go's, be sure to check out the Ready Set Go videos in the student support site in Canvas.